All right, students, this is going to be part 3 of the notes 4.2. Make sure you watch the previous videos as well to know how to do this. So this topic is about circumcenter, which is new to all of you. So the circumcenter is created whenever the perpendicular bisectors of the sides of a triangle intersect at a point, and that will be called circumcenter. So look at the side. Imagine you have a perpendicular bisector right there, which in this case, it will be this right here because of the 90 degree. And then imagine you have BC and the perpendicular bisector to that because of the 90 degree. It's going to go like this. And then the other side AB, the perpendicular bisector to that because of this 90 degree goes like this. So notice that all of these three lines meet in that middle part. That middle part will be called circumcenter. The circumcenter is always equidistant from the vertices of the triangle. So that's what these other black lines are. They're telling you that from here to here, and from here to here, and from here to here, these are all equidistant. Okay, so that means whatever this side length is, it's also here and it's also here. They're equidistant. They're equal in distance. All right, so now with that information, you can make conclusions out of that. For example, using the diagram below or to the left, answer the following questions. List the perpendicular bisectors. So I know it stops there because of my highlighted examples. They're keep going. So that means it creates a little tiny segment right there, and right there. So PF, that's the yellow one. And then PE, this one right here, that's the pink one. And then PD, this one right here. So that's the purple one. So those are the perpendicular bisectors right there, and right there. That creates that middle point, and that's going to be the letter P, that point P. Therefore, list all the congruent segments. So we're going to say that A to D is congruent to D to B because of the perpendicular bisector. These two are equal. Then B to E is congruent to E to C because, again, of the perpendicular bisector making these be equal. AF is congruent to FC. So these two are equal because of the perpendicular bisector. And then also we're going to say AB, the whole thing, BP, I'm sorry, wait a minute, AP, that's a P. AP, AP, BP, and CP are all congruent. So that's what these three are next to each other. A lot of congruency. So let's apply it in these three examples below. We need to identify what you're being given and how you can answer what's missing. Say it says find each measure using the information given. So it's saying Z is the circumcenter of TUV. Z, it's the circumcenter of TUV. That must mean that there's a perpendicular bisector right here, there's a perpendicular bisector right here, and there's a perpendicular bisector right here. Which means, if I zoom this in, this means that we have equal side lengths right here, equal side lengths right here, and equal side lengths right here. And then also what that means is that the distance from the circumcenter to each vertex is also equal. So I'm just going to draw 4 dashes for those. Okay. Now it's telling you the whole thing is 34 from here to here. So we are going to assume that if we need it, we can cut this in half, and that will give us these two side lengths separately. They're giving you a 19, and that must mean that this side is also 19. They're giving you a 15 in here as a perpendicular bisector. They're giving you a 2. Let me see, where does that 2 apply? I'm not sure yet where that 2 applies, so I'll double check on that. We can assume that we are missing a side here, and I believe this is 90 degrees as well. So 15 and 21. Yes, that's where the 21 is. So 15 and 21, and then the third side is what we're missing. Actually, 21 is referring to this, the hypotenuse. So 15 right here, missing a side, and the 21 is there. So we're going to do Pythagorean theorem for that to find what that missing side is. Now, why are we needing that side? Well, let's look over here. This is what we need to answer. TU. T to U. So TU is from here to here, and we know that halfway it's 19. So the other half will be 19 as well. So together, this results in 38. Okay, next is VY. So from V to Y. So from V to Y, we know that the whole thing is 34 from V to U, and then Y is in the middle. So V to Y is cutting 34 in half. So 34 divided by 2, that's 17. So 17 goes right here. Next is UZ. We look at U, we look at Z, and we identified this side length as 21, so that must mean that this is also 21, and that must mean that this is also 21. So UZ, it's from the center to U, and then from the center to V. And we know that this is 21, so therefore this is also 21. Okay, WB. So that's the part that we were discussing earlier. WB, we don't know that side length, but we know that this is 15 and that's 21. So imagine to find WV, we need to look at the triangle that's formed. This is 15, this is 21, and we don't know what that is. But we do know that the 90 degree is there. So 90 degree tells you right across, that's your C value. And then this is your A value, this is your B value. So we're going to do A squared plus B squared equals C squared. We're going to do A squared plus 15 squared equals 21 squared. And 15 squared, I believe, is 225. Let me see. Yep, so A squared plus 225 equals 21 squared, which is 441. And we're going to subtract 225 from that. And that gives us 216. So A squared equals 216. And then the square root of that would be 14.7. That was a long way, but that right there, 14.7, is that missing side that we have here, which means that if you go and look at this image, this missing side length from here to here is that 14.7. So let's write it right here, 14.7. All right, I'm gonna bold this so that way you know that this is the end of that first example. TV, so let's look at TV. T to V. T to V is these two combined. So if you already know this is 14.7, then you just gotta double it again and have these two combine each other. So for TV, we're going to add or multiply 2 times 14.7. So that will result in 29.4. So I'm gonna divide this work based on what we did, like this, just to not confuse you because of the space. There. So let me zoom this out. Let's put 29.4 right here. And all of this work was done to find these answers. Okay, so don't be afraid to show your work. If this space is too little, then maybe put it in your journal and your notebook to have that freedom of writing as big as you would like. All right, let's try the next example. Here, they're telling you H is a circumcenter. And so if you start annotating all the facts, we know that this is 90 degree, 90 degree, and 90 degree. This is the same as that one. These are the same, and these are the same as well. The other thing to annotate is the equidistant segments from the circumcenter to the vertices. These are all equal to each other. So now let's see what they're asking. They're asking for GD. So let's see, GD from here to here. We have the whole thing being 24. So we just gotta find out what half of that is. So for GD, we have to do 24 divided by 2, which equals 12. Okay, so that's 12 right there. For BC, which is the next one, we have to, let's see, BC, the whole thing from here to here. And we already know that this part is 7 and the middle part 7. So now we're going to do for BC, we're going to do 2 times 7, which is 14. Okay, next is EH. So let's look at EH, which is from here to here. So this is the part that you look and see, what am I given? You're given 13 right here. You're given this side length right here because of that 7. So let's sketch that separately. For EH, we have a triangle created like this. This is 90 degree. This is 13. This is 7. And that side is the one we don't know. So right across the 90 degree, we have the C value, and then the others are your A and B. So let's do Pythagorean theorem for that one. A squared plus B squared equals C squared. And we're going to have 7 squared plus B squared equals 13 squared. And that results in 49 plus B squared equals 169. We subtract the 49 from both sides. We have B squared equals, I believe is 120. So if we do square root of that, we get B equals 11 point, let me see, square root of 120 yes, so that rounds to 10.95, which it rounds up to 10 point, I guess it rounds up to 11 because 95 rounds up 9 and then 9 becomes a 10, so then it becomes 11. So we're gonna say E is 11, which means that this side length is 11. So EH E to H is 11. All right, after that we have FD. So F to D is this part. What are you given? You're given a 90-degree, which means you have this side length right here of 3. You have this side length of 13 because these are all equal. And you don't know what FD is. So we're going to have to do Pythagorean theorem again for this triangle. So for FD, we're going to draw the triangle that looks like this. And we know that this is 3 and this one is 13, but we don't know that side. And right across the 90-degree, we have the C value, and then the legs are A and B. So I'm going to try it again here somehow in this space. We're going to have A squared plus B squared equals C squared. And I'm going to sketch this around this so I don't mix it up. We're going to have A squared, which is 3 squared, plus B squared equals 13 squared. And then 3 squared is 3 times 3, which is 9, plus B squared equals 169. Then we're going to subtract 9, and B squared equals 160. So then when we do the square root for that, we get B equals 12.6 if you round it. So this side length is going to be 12.6. This right here, 12.6. So that's that part. Okay, so the last one for this problem is going to be CD. So from C to D. So now that you found this side, we have the same 12.6 over here. And we are going to add those two. Okay, so I'm going to just do it right here somewhere and squeeze some space. I'm going to write CD equals 2 times 12.6. And 12.6 times 2 is going to be 25.2. Okay, so the answer is 25.2. All right, sorry for all the messy writing. That's just the way my brain works. Again, use your notebook for extra space. Last problem, let's go over it together. They're saying the M is the circumcenter. So to annotate what that means, it means that this is the perpendicular bisector, this is the perpendicular bisector, and this is the perpendicular bisector, which means that these two are equal, these two are equal, these are also equal. And then one last thing to annotate is that the distance from the circumcenter to each vertex is also equidistant. Okay? Without these annotations, you're gonna have to still make those relationships of what you're given. So my strong suggestion is to annotate all this first and then answer what it's asking. So it's asking for GI first. G and I. And G to I is this whole thing right here. You know that from here to here is 30, so you have to have 30 here and 30 there. So that's an easy one. We're just gonna add those or multiply times 2, and that will be 60. Okay, so that's the first answer. Next is MH. So looking at this diagram, MH is this part right here. So if you look at this, you are needing to find what numbers are they giving you. So I believe this one we do need to do, let's see, 23, 14. I think we're going to have to do that Pythagorean theorem. So we can use, let's see, this side length is given, and we know this is 14. So let's use that to find this measure, which applies to all of these. So let's do for MH, we are going to look at the triangle created by G, J, and M. There's a 90-degree right there. This distance is 31. This distance is 14. And this is the distance we don't know. So 90 degrees right there, right across as that is C. A and B are attached. And then I'm going to do it right here on the bottom. A squared plus B squared equals C squared. If we substitute the values, we're going to have A 31 squared, B is 14 squared, and C is what we don't have. So let's do 31 squared and 14 squared. Let me see. Calculator. 31 squared. It's 961. 14 squared. It's 196. We're going to add those two. And it gives you 1,157. So now we're going to do the square root to square root. So square root of 1,157. And you get 34.01. So we could round it or leave it like that. But that right there is this distance, which means that that's this part, the 34.01. 34.01. Which means that this is also 34.01. And then this is also 34.01. We're looking for MH. MH is right there. So we're just going to say it equals 34.01. Okay. IK is this part. So now that we know what this is, and we know that this is 23, we're going to have to do Pythagorean theorem to find what this side is. IK. So let's do that now. IK. Let me separate this into sections so it won't look confusing. So IK is going to be analyzed by looking at the triangle from M to K to I. And we know that this distance right here is 23, because that's what it shows right there. MK is 23. We know that this distance is the equidistant of 34.01, but let's just round it to 34, just to not work with that decimal for now. And then IK is what we're trying to find out. So across from the 90 degree is 34, so this is your C, A, B. And then we're going to do A squared plus B squared equals C squared. A squared is 23 squared plus, we don't have a B, so B squared. And then C squared is 34 squared. So then we have 23 squared, which is 529, plus B squared equals 34 squared. So that's 1,156. To solve for B, we're going to have to subtract 529 from this side and that side. That's going to bring down B squared equals 1,156 minus 529. That is 627. Square root that, and we get, let's see, 25. So that's 25.04. So that means that this I to K, it's that 25.04. And that could be rounded to 25, just like this could be rounded to 34. All right, last two. We have HI. So let's look at that. We have H to I. So we just found out IK. That was 25.04, or rounding it to 25. if we're looking for HI, we're looking at doubling that because these two are equal. So we're just going to do here an annotation that HI is calculated by doubling that 25. So that's 50. 50. Okay. Last one is MG. So let's look at that. M to G. And since we calculated that earlier to find this side and that side, we just answer it. So 34.01, which rounds to 34. All right, that was intense for this little one page of 3 examples. A lot of annotations, a lot of work behind it. So please use scratch paper whenever working on these topics, or better yet, use your notebook. That way you can look back at how to do stuff. All right, thank you for watching this video.